Good morning, Chippewa Hills High School chemistry students. This is my second recording of this, somehow I accidentally stopped making it. So I'm going to start over, and I apologize, some things are already written on the slides for you. So balancing chemical equations. The definition of a balanced equation is a complete description of the reaction, including both the kinds and quantities required. Okay, so remember kind of where we're starting at here. This is kind of our ultimate goal, but we've started with a sentence or paragraph, and that sentence or paragraph, the first thing we do is write that word equation. Again, the purpose of writing that word equation is that it allows us to get rid of extra information that we don't need. Remember, after that word equation, we talked about the fact that we were writing a skeleton equation, which was an unbalanced chemical equation. So now we're talking about this balanced equation, which is a complete description of the reaction, including both the kinds and quantities. Our skeleton equation still has the correct the kinds. The difference between a skeleton equation and a balanced equation is now we have the correct quantities required. So again, the big difference, between a skeleton equation that we've already talked about and this balanced equation that we're talking about now is that this balanced chemical equation gives us the correct quantity of each reactant and product. To balance a chemical equation, we're going to use a coefficient. A coefficient is a number placed in front of the symbol or formulas in a chemical equation. So this is a whole number that we're going to place in front of our chemical formula. Remember when we talked about writing our skeleton equations, I told you that you would want to make sure you left space in front of your formulas. The reason you need to leave that space is because you may have to put a coefficient there. A coefficient is used to balance a chemical equation. Our balanced chemical equation must follow the law of conservation of mass, which means the numbers of atoms on the reactant side of our equation are going to have to be equal to the number of atoms on the product side of our equation. And again, the way that we're going to accomplish that is that we're going to use a coefficient. So this coefficient is a whole number that's placed in front of the formula, the symbols or the formulas. So an example of what a coefficient might look like is I might have the formula water in my skeleton equation, and perhaps to balance it I need 3 oxygens. So I'm going to put a coefficient of 3 in front of it. Again, this 3 in front of it means that I have 3 oxygens now, and this 3 in front of it also corresponds to our hydrogen, so now we would have 6 hydrogens instead of what we had before, which was just 2 hydrogens and 1 oxygen. So again, our goal being to have this balanced equation. In our balanced equation, each side of the equation has the same number of atoms of each element. Again, remember, I told you when we talked about the law of conservation of mass that you would become atom counters. And you're going to be counting to see that the numbers of atoms of your reactants equals the numbers of atoms of your products. Again, the reason that we can do this is because the mass of our elements doesn't change in the process of the chemical equation. So rather than having to do a bunch of math to see that our equation is following the law of conservation of mass, because the mass of an atom doesn't change in the process, we just have to count the number of atoms. As long as we have same numbers of atoms on both sides of our chemical equation, the reactant side and the product side, then we know that our equation is properly balanced. So What are those steps? The steps for balancing a chemical equation are, again, kind of going back to where we started. You're going to be starting with either that sentence or that paragraph. And so the very first thing that you're going to want to do is to write a word equation. Remember, the only symbols that we have in our word equation are plus signs and arrows. So again, remember the purpose of our sentence becoming a word equation before we get started here is so that we get rid of that extra information that we don't need. Once we have our word equation, now we're going to start to work towards writing our balanced chemical equation. The first thing that we're going to do is we're going to actually just start by writing our arrow. Again, we're going to want to put our arrow towards the middle because, again, we want to make sure that we have room to write our reactants on our left and our products on the right. The next step of writing our balanced chemical equation is that we have to write the correct formula for each substance. Again, this goes back then to you remembering what you've learned before about molecular compounds, ionic compounds, and your diatomic molecules. You cannot correctly balance a chemical equation if your formula for your compounds or your elements are incorrect. So it's super important that you remember how to write formulas. Again, for the most part, you're going to be given names, how to write the formula. Remember, for a molecular compound, your prefixes become your subscripts in your chemical formulas. For ionic compounds, again, you know that a compound is ionic because it's made of a metal and a nonmetal, or it has a polyatomic ion. And for your ionic compounds, when you're given the name and asked to write the formula, again, you're going to do those 4 steps. You should be able to rattle those 4 steps off, right? You're going to do symbols, charges, crisscross, lowest whole number ratio. Lastly, you have to remember about your diatomic molecules, that Dr. Brinkelhoff, because again, as we start to write and balance chemical equations, it will be important that we correctly write diatomic molecules as being diatomic. So, again, we've taken our sentence, we've made a word equation. From our word equation now, we have written the correct formulas for each substance. Our third step then is that we're going to place that formula on the correct side of the arrow, depending on whether it's a reactant, so it goes on the left, or a product and it goes on the right. At this point, you have a skeleton equation. So again, we've done this, you've done this already, right? We practiced writing some skeleton equations the other day. Remember, in our skeleton equation, we're going to use a plus sign to separate multiple reactants or products. So if we have more than one reactant or more than one product, we use a plus sign between those to separate them. And very, very important here, once our formulas are correct, you may not change them. Why? Well, remember, if I'm trying to balance my chemical equation and I have water, and let's say that I need 2 oxygens and I'm struggling, so I decide to change my formula to H2O2. The problem with that is that's not the same substance anymore. H2O is water. If it's a hot day, I want to take a nice cold drink of water. However, to change that formula to H2O2, now I have hydrogen peroxide. On a hot day, I don't want to take a big drink of nice and refreshing hydrogen peroxide. So it's super important that you remember that once you have written your formulas correctly, and that's why you need to take your time and think about, is this compound ionic or molecular, and follow your steps. And again, if that's something you're struggling with, remember back in chapter 6, you made a flow chart for doing that, okay? Once you know your formulas are correct, you may not change them as you start to work at balancing your chemical equation. Step number 4. Now you're going to place your coefficients in front of the formulas to make the number of atoms of each element of the same on both sides of the arrow. So again, this is where you're becoming an atom counter. Now, what is nice about this is there's not any particular spot you have to start to do this. I will tell you as we work through some examples here in just a couple minutes, I am a super duper linear thinker. So I almost always will start at the left side and work that way. That doesn't mean you have to do it that way, okay? It's just the easiest way for me to do it. It doesn't mean that you have to do it. What is nice about this is that 2 different people can start in different spots and they're still going to arrive at the same balanced chemical equation. Now, this sounds pretty easy, but this is the hard part of balancing chemical equations. So I have some suggestions for you, okay? So these suggestions. First one, work, okay, 1 atom at a time. Use a pencil so you can make changes. Again, you're going to have a small space in front of your chemical formulas. You're not going to have a lot of space to kind of have to scratch things out. Okay? Remember, when you think you're all done, to double check that you will be taking any quizzes right now, given these extenuating circumstances. However, if at some point you were to take a quiz, can't tell you how often I see people who, as soon as they get their quiz back and they see something's marked wrong, they realize right away it was wrong because they just didn't take the time when they thought they were finished to go back through and double check that they had the same number of atoms on the reactants and product side. And sometimes, for whatever reason, when you're trying to balance it, you don't see that lowest whole number ratio. So you want to always check that your coefficients must be the lowest whole number ratio. And again, sometimes just for whatever reason, you struggle to see that lowest whole number ratio. You see some multiple of it. But if you take a moment and look at your coefficients, let's say you had a coefficient of 2, 4, and 6 when you were done balancing. You would look at that and say, oh wait, 2, 4, 6, that's not the lowest whole number ratio. I'm going to change those to 1, 2, and 3. Okay, so that's just a way. The last thing, and this will be particularly important as we get into talking about combustion reactions, is you want to leave hydrogen and oxygen, okay, until the end, if possible. Oftentimes, hydrogen and oxygen will be the most difficult elements to balance. And so sometimes if you will just start somewhere else, by the time you get back to doing hydrogen and oxygen at the end, they will have worked themselves out. So that makes it easier. And then lastly, you want to count polyatomic ions as a group if possible. So when will that be possible? That's going to be when you have the polyatomic ion appearing as exactly the same polyatomic ion on both sides of the equation. So maybe you have aluminum sulfate as one of your reactants and calcium sulfate as one of your products. Rather than counting sulfate as 1S and 4 oxygen, you're going to count the whole sulfate groups as SO4. This goes back to why it is so very important that you remember how to correctly write your polyatomic ions, and why I've asked you to balance or to memorize those 10, because it's going to be easier for you to recognize them and then to work from there. So we're going to move on to some examples of using all of this then that we've talked about today. We are going to do 5 examples here. Okay, so our first example, and this example was from earlier in your notes. You had the sentence that hydrogen reacts with oxygen to form hydrogen peroxide. This is our sentence. Remember, the first thing that we want to do is we want to make this our word equation. So again, we're going to get rid of things like reacts with, to form, okay? And those are going to become symbols. So our word equation for this is going to be hydrogen. Remember, reacts with is going to become a plus. Oxygen. To form is going to become an arrow, and we're going to have hydrogen peroxide. So that's our word equation. Now we want to work through those steps to writing our balanced chemical equation, okay? So we're going to put our arrow kind of towards the middle. And we need to write the formula of each substance, and we have to put it on the correct side of the arrow. So hydrogen's a reactant, so I'm going to write H2. Why am I writing it as H2? Right, because it's part of Dr. Brinkelhoff and it has to be diatomic. Plus, and again, remember, I want to make sure I'm leaving myself room. Again, I'm going to do O2. Why am I doing O2? Yes, once again, same reason. It is diatomic. It's part of Dr. Brinkelhoff, and so we have to write it as O2. And our formula for hydrogen peroxide is H2O2. So that's our skeleton equation. Now we need to balance this. So to balance this, again, we're checking to see, do we have the same number of reactant of all the atoms on both sides of the equation? So we have, okay, 2 hydrogens here. We have 2 hydrogens here. We have 2 oxygens here. We have 2 oxygens here. Our equation, our skeleton equation in this case, also happens to be a balanced equation. Because in this case, we don't need any coefficients to make this a balanced equation. And this happens quite often, okay, that your skeleton equation will also be a balanced chemical equation. So that's our first example. Our second example, again, another one that you've already seen on your outline and in our chapter, our iron reacts with oxygen yielding iron 3 oxide, also known as rust. So again, reacts with and yielding, those are going to become symbols in our word equation. So our word equation is iron plus oxygen, arrow, iron, 3, oxide. And again, the also known as rust is extra information that we can leave out. So now we have our word equation. Our next step is we need to write our balanced chemical equation. And the first thing we're going to do that is we're going to write our formulas, making sure we put them on the correct side of our arrow and leaving space in front of them for coefficients if it's needed. So we're going to start with our symbol for iron, which is Fe, plus, I'm going to leave a little bit of space before I write oxygen. And again, am I going to write oxygen as O? Nope. I have to write oxygen as O2 because it's all by itself. It's not in a compound, and oxygen always exists as a diatomic molecule. So that brings me to my compound here. Remember, because it's a compound, I have to ask that question. Is this compound ionic or molecular? It's ionic because it's made of a metal and a nonmetal. All right, because it's ionic, remember then that means to write my chemical formula, I'm going to do symbols, charges, crisscross, lowest whole number ratio. So my symbol for iron is Fe, and again, I've left myself room to put a coefficient in front of it. What's the charge on iron here? Remember the 3 Roman numeral is telling me the charge on my iron, so it's plus 3. Oxide is the formula O, and I know that it has a charge of -2 because it's in group 6A. So I have my symbols and my charges. I crisscross, so my 2 and my 3. So now I have a skeleton equation. Now, is this skeleton equation a balanced chemical equation like our last example? Nope. Notice right now I have 1 iron on the reactant side, 2 irons on the product side. I have 2 oxygens on the reactant side and 3 oxygens on the product side. Now, this is one, again, I told you, I'm a person that I always start just at the left. So I look at my iron and I see I have only 1 oxygen here, and I have 2 oxygens here. So to balance it, I need a coefficient of 2. Next, I look at my oxygen. I have 2 oxygens here, and I have 3 oxygens here. Well, the number I'm going to be able to make them both is 6, right? So how do I get 6 oxygens right here? Well, I need a coefficient of 3. How do I get 6 oxygens over here? I need a coefficient of 2. Now remember, I have to put my coefficient out in front of my whole chemical formula. So I think I'm done. I want to check. I have 2 irons. I have 4 irons. Uh-oh. Again, this is why we're working with a pencil. It's going to happen, right? I'm going to have to change that number because now this number needs to be 4 instead. So again, I think I'm done. I'm going to check it out. So I have 4 irons here. I have 2 times 2, so I have 4 irons here. 3 times 2, I have 6 oxygens here. 2 times 3, I have 6 oxygens here. My equation is now a balanced chemical equation. Now I want to double check. Do I have the lowest whole number ratio of coefficients? 4, 3, 2. Yes, that's the lowest whole number ratio. I can't change that at all, so this is my properly balanced chemical equation. Our next one, again, this is an example that we've already seen on our outline about methane is burned with oxygen, producing carbon dioxide and water. Our word equation, methane plus oxygen, arrow carbon dioxide, plus water. So that's our word equation. Again, we got rid of the is burned with and the producing and made them formulas as well as and. So now that I have my word equation, again, I'm going to start to write my formulas. Methane, this is not one you know, but methane, some of you might know it, but it's CH4 plus oxygen. Again, oxygen has to be O2 because it's part of Dr. Brinkelhoff. Carbon dioxide is CO2. And water is H2O. So again, remember I told you to try to leave oxygen and hydrogen until the end. So as I start to work through this, to do that, that means I'm going to start with my carbon. I have one here and I have one here. So that looks okay. So now the question is, should I do oxygen or hydrogen? My suggestion is to do hydrogen next, because notice hydrogen's only in one reactant and one product. So it'll probably be a little easier than oxygen. So if I start with my hydrogen, right, I have 4 hydrogens on the reactant side and 2 hydrogens on the product. So to make them equal, I need a coefficient of 2 in front of water. So that brings me down to oxygen, correct? So for oxygen, I have 2 oxygens here, and notice I have 2 here because of that coefficient. So I have 2 plus 2, which makes a total of 4 oxygen. Well, it's pretty easy for me to get 4 oxygens over here. I just need a coefficient of 2. So I want to check this and make sure that it's correct. So here I have 1 carbon, 1 carbon. That looks good. Here I have 4 hydrogens, and I have 4 hydrogens here because 2 times 2 makes 4. Here I have 2 times 2, which makes 4 oxygen. I have 2 oxygen here plus the 2 oxygen here makes 4. So this is a correctly balanced chemical equation. So, taking a look at our next example, aluminum sulfate reacts with calcium hydroxide, producing aluminum hydroxide and calcium sulfate. Again, I want to write that balance or that word equation first. So I have aluminum sulfate reacts with, becomes that plus calcium hydroxide, producing becomes that arrow, aluminum hydroxide plus calcium sulfate. Okay, so that's our word equation. Now we need to make this a skeleton equation. So we need to make these formulas. So this first compound here, aluminum sulfate, that is an ionic compound. I know because I see that polyatomic ion I have memorized in it. So my symbol is Al. Charge is plus 3 because it's in group 3A. Sulfate is SO4. The charge of negative 2. So I have my symbols charges I have to crisscross. And I'm going to need multiple sulfate, so I need to put it in parentheses. Next, I'm going to work on calcium hydroxide. Again, I know it's it has a hydroxide, it's a polyatomic ion, so my symbol is Ca. Positive 2 charge, because it's in group 2A, OH. Negative 1. I'm going to crisscross, so I need parentheses 2. Oops. Now I'm ready for my arrow. I'm on to aluminum hydroxide. So again, Al plus 3. Hydroxide OH -1, so we need a 3, plus, and if I had more space, I'd make sure it was all on one line, but I'm sorry. So calcium is a Ca plus 2, sulfates SO4, -2, so nothing to do to that one. Okay, so we have our skeleton equation now. Again, now that I have this, I can't change my subscripts. I've correctly written all my formulas, and now I just need to balance them. Again, I start here, okay. Aluminum, I have 2 aluminums. Over here, I only have 1. So I'm going to do a coefficient of 2. I look at my sulfate because my sulfate stays the same and I have 3 of them. And over here I just have 1, so I need a coefficient of 3. Here's my calcium. I have 1. Now I have 3. So I need a coefficient of 3. So I look at my hydroxide. I have 6 of them here, and I have 6 of them here. So I think it's balanced. Again, I'm going to kind of do that double check here. Okay, so I want to make sure that it is correctly balanced because I think I'm done. So right here I have 2 aluminums, and over here I have 2 aluminums because of the coefficient. I have 3 sulfates here, and I have 3 sulfates here. I have 3 calciums here, and I have 3 calciums here. I have 6 hydroxides here, and I have 2 times 3, 6 hydroxides here. My equation is now a properly balanced chemical equation. Our last example. Hydrogen phosphate reacts with sodium hydroxide, yielding sodium phosphate and water. So again, I'm going to start with my word equation. So hydrogen phosphate reacts with is a plus, sodium hydroxide, yielding is an arrow, sodium phosphate, and is a plus, water. So now I want to take this word equation and make it a skeleton equation. I have to write formulas. Again, hydrogen phosphate, that is an ionic compound, so my symbol is H, charge of +1. Phosphate you have memorized is PO4, charge of -3. So I have to write this as H3PO4 plus sodium hydroxide, right? That's our next one. Again, that's an ionic compound. Hydroxide's a polyatomic ion you have memorized. So Na +1, hydroxide OH, -1. Nothing to do to that one. Next I have sodium phosphate. So again, sodium phosphate, ionic compound, symbol is Na, charge of +1, phosphate PO4, charge of -3, so this has to be Na3PO4 plus water. Now, I'm going to write water a little differently here, and here's why. This reaction, if you kind of look at it, what's taking place is sodium and hydrogen here. They're kind of swapping partners. And so because of that, I know that it's going to be a little bit easier for me to balance this equation if I write water as HOH. So oftentimes, when you see hydroxide in our chemical equation, it's going to be easier to balance it if one of your products is water, if you write water as HOH, right? That's still water. It's still two hydrogens and an oxygen. So I'll show you why that makes it a little bit easier to balance. Again, this becomes that. This hydrogen is right here. Okay, so as I start to think about balancing this, right here, I have 3 hydrogens, and here I only have 1. So how do I make them equal? A coefficient of 3. Here I have 1 phosphate. Here I have 1 phosphate, so that's balanced. Here I have 1 sodium. Here I have 3 sodiums, so I have to make that equal, so I'm going to add my coefficient of 3 in front of sodium hydroxide. Here I have now, right, 3 hydroxides. Here I have 3 hydroxides. So it would appear that this is a balanced chemical equation. Again, let's do a little check and make sure. So again, right here, I have 3 hydrogens, and here I have 3 hydrogens. 1 phosphate, 1 phosphate. 3 sodiums, 3 sodiums. 3 hydroxides, 3 hydroxides. This is now a balanced chemical equation. So again, that's a little trick to use if you have a hydroxide as a reactant and a water as a product. You may find it's easier to balance the equation if you make water or write water as HOH. So your homework is to do on page 211, exercises 10 and 12. Have a great day, and I will talk to you later.